Hello everyone. In this short video, I just wanted to focus on the remaining questions that use a type of list to work with your code, and how we can use recursion to kind of go over these lists. So before we even delve into using recursive functions with them, the main purpose of these lists, and the videos kind of show them as well on how these guys run, is that each list has parameters on them, or excuse me, methods on them that we're very familiar with of these indexing. And the concept of recursion is that we're going to try to gradually reduce our problem size to something that's more manageable. So how does this apply to lists so much? Well, there's a special keyword in list that gives us to the end of a list, and what that is one and a colon sign. And you'll see here that if I do in this list up there, 1 to 3, what it gives me is the values between the first index and the second index. So this is exclusive. So what it means is it goes go to 1 and 1 less than the second value. So if I do list of 1 to 4, of course, that will give me from index 1 up to 3. Now, what happens if I don't provide the second parameter? Well, what it does is it kind of gives me from the index I provided to until the end of my list there, okay? So if I do 2 like this one, my list is still unchanged, but I go from the second index all the way to the end. Now, why is this important for us to use here? Well, if I use list of 1 until the end, what I get here is the remainder of my list besides the first item in my list. So we'll see here that the general idea that we're approaching is to gradually reduce the list size of our problem. We're going to be using this syntax of 1 until the end. And now this is essentially how you would do it in any programming language. You can also increment the index value, but for Python, it's much easier to just use this type of syntax rather than dealing with, indexes out of bounds and stuff like that as well. Okay, so to kind of go ahead and approach the first list problem, I won't give the solutions to these, but I'll just kind of give us a big hint, and then we can go into actually parsing lists within lists as well. Is we can go ahead and try to take a look at a general list with strings in them. So I'll go ahead and make a method called getStringList. I'll go ahead and make a parameter called LST. You're most likely going to use this in your templates as well. And what we could do here is I'm going to go ahead, or I'll say get number list right here. And we could say here I'm going to return, let's just say get numList. And then what I'll do is I'll get the remainder of my list there, okay? And we'll say here, if I go ahead and run this guy, get numList that the list is given, we can see here that I'm getting the maximum recursion depth exceeded. But if I just print out my list, we'll see I get that, oops, try to pause that one. If I go back up to the top, we'll see that I get 5, 4, 3, 2, 1, 4, 3, 2, 1, 3, 2, 1, 2, 1, 1, and then of course I get my recursion. So what's the base case I should use for my list here? Most likely, if my length of my list is equal to 0, what I'm going to do is just return nothing. And if I try to run this guy, we can see here that I get a really neat output of my list gradually getting smaller. So that's my base case there. And this will be my recursive step. So my recursive step is actually doing the recursive call on the remainder of the list with 1 removed. So the top guy truncated. That's kind of the word that we use. We remove it there. And what's the purpose of doing all this, though? How do I actually get the values from there? Well, if I go ahead and instead of printing out the full list, I print out the list of 0, we'll see here what I get is actually the first value of each item in my list. So what we're actually getting now is each of these values individually. And we can see here that using this logic and looking at these problems, we could see that I'm getting, I have access to each of these guys individually here. So we could see here I get from 10 over to 0, and then 5. And let's take a look if there's any other list here. That's just the string one. So we could see here I'm now able to access each of these guys individually. And we could see that we can actually modify the values of it as well. So there's one called rec adder here for us to work with, but we can see that I have now access to each of these guys. And what's the purpose of having access to them? Well, what I could do now is try to return, instead of adding them up, let's try to do a multiplication of them. What I can return now, if I go to the end here, is list of 0 times the recursive call of getNumList. And unfortunately, in this scenario, it looks like I'm getting an unsupported operand type for multiplication, int and none type. And in my scenario, what happens again is that once we hit this base case, I'm returning nothing. And because I'm returning nothing, nothing gets outputted for me. And this is something that we saw in the parameter passing video. So instead of returning nothing, what happens if I return 1? We'll see here I get 120. And what is 120? Well, my list is of 1, 2, 3, and 4. Let me try to do it this way. Nice. I'm getting 120 there. So that's essentially how I can go through my list here. Now, what happens if I do something a bit different here? What happens if I add an A or a B or a C into my list? Sorry, what did I call it? GetNumList. Let me do it this way. So if I do getNumList of my list here, we'll see here I get an error, type error, can't multiply sequence by non-type of type string, which makes sense because what I'm returning is 1, and then I do 1 times 1, 1 times 2, 1 times 3, 1 times 4, 1 times C, which doesn't work. So how do I actually do this recursive step now? Well, I'm going to need probably 2 steps here. I'm going to first need to check if the type of my list of 1 is something appropriate to do a recursive call on, right? So what happens if my type of list of 1 is equal to string? Let me try, oh, excuse me, not 1. Let me type a list of 0. Let me go ahead and to say something of a print, like found a string. And let's just see if this works for us. And nice, we have 3 strings in our code, and we found 3 of them here with our recursion. So that's good for us. We have this found a string working. But what does this actually do for us? How do I not recurse over it? Well, essentially what you would want to do is that if you are currently on list of 0, and let's just say that I have these guys truncated, so my list only looks like this right now. What I would like to do is just skip over him, right? I want to just skip him and leave him where he is because he's not appropriate for my code. So essentially what we can say here is instead of returning list of 0 times that one, I can return getNumList to the remainder of my guys. So what I could say here is, you know what, skip over him. I don't want to deal with him. Now I can continue forward. And it looks like now my code is working. And because this is happening, I return it here. And then this one is never ran. So I never multiply it. If this looks a bit confusing, you can also just do an else statement here. That might be more appropriate just to make it more code heavy. So it's good. Now, what happens if I encounter a scenario where I go ahead and I have this embedded list inside of my code? This is where it can get a bit confusing, and we'll look more at this in the next week here. But we'll see here that what I get returned is actually an empty list because I multiply ints by an empty list. So essentially what you could check for as well is if the type that I'm currently on is of type list, instead of skipping over the rest of it there, we could try to go into it as well. So we'll look at this next week too. But the general idea is that if you want to look into this list here, you're going to most likely do a recursive call on this list of 0 as well. So what happens here is now I jump into this list to see what's inside of there. And let's see what happens in my code if I do it this way. And we'll see here I'm only getting 5. And the reason I'm getting 5 is that what happens is that this code runs and it deletes everything else that I was doing up until that point. So essentially, if you ever encounter a list, you're going to make sure that you do the recursive calls on each item of that list there. Okay? Oh, and let me do, actually, maybe it might be plus there. Oh, that's supposed to be 1 to the end instead of the 0. Nice. And what happens here is essentially it says recurse on the first guy inside of my list and then do the remainder of it as well, keep track of it. And why do I need to do this? Well, what happens if you're given a piece of code that has stuff inside of it as a list, like so? And let's actually try to see how much this is here. So what it should be is, let me do print 5 times 5 times 4 times 3 times 4 times 3 times 2 times 1. Okay, so this gives me 7200, and if I do get num list of list, I get my 7200. So this is in general how you can recurse over list in Python, and now you can also recurse over list of lists. So if you have a list of lists, you are going to need a type of code that looks like this there. So this is similar to the assignment. There's a few different scenarios, but in general, this is how you recurse over lists. And any questions, just let me know via email. Thank you, everyone.